Doobie doobie doo. Okay, looks like we have an easy today. Hopefully it's not too Orwellian. Minimum difference between highest and lowest k-scores. You're given a zero index integer array nums, where nums at I represents the score of the ith student. Sure. You're also given an integer k. Pick the scores of any k students from the array so that the difference between the highest and lowest of the k scores is minimized. Return the minimum possible difference. Okay, minimum, the highest and lowest k scores. The difference between the highest. Pick the scores of any k students from the array. Okay, so let's look at examples. 190. Well, if you just pick 90, then the highest and lowest is difference of 0. 9417, k is 2, so you pick 2 students, 9 and 7, I think. The difference there is 2. Alright, so I think this is pretty simply best done with sorting, right? So if you sort them, and k would just be the number of consecutive elements of that sort. So k is 2, then if you look at 1, 4, 7, 9, it's either 1, 4, or 4, 7, or 7, 9 as the two students that you would choose, the 2 scores that you choose. Because, like, obviously, if you want to minimize differences, then you just pick the cluster of sorted scores, right? The cluster of sorted consecutive scores. So, so I think it's starting to sort. And then if I wanted to do k, then at index I, it'd be index I plus k or so, or index I plus k minus 1, one of those two, to find the ending score that you'd have for the consecutive scores. So I think it's using answer equals a high value, and then we're going to minimize it. So for every index in range n minus k, where n is the length of nums, I think it might be n minus k minus 1. So if k is 1 and n is 1, then it should be 1. I think it's n minus k plus 1 actually. Is that right? N is 1, k is 1. Yeah, I think it should be n minus k plus 1. And then let's say the first score is going to be nums set I, and the last score in the consecutive group is going to be nums set I plus k minus 1, I'm going to say. So if you have k is 1, you're doing I equals 1, then be 1 plus 1 minus 1, which is 0. No, k is 1, I is 0. 0 plus 1 minus 1, yeah. And then if answer is bigger than last minus first, answer equals last minus first. Okay, I think this might be right. All right. Huh. This is surprisingly slow. Surprisingly slow. Why is it so slow? I think maybe I can not define the variables here and just use straight indexing, because it does take two kind of statements to do these. So if answer is greater than last, which is nums at I plus k minus 1 minus nums at I, answer equals nums at I plus k minus 1 minus nums at I. I think maybe that's an improvement. Okay, there's still things that go much faster than this. Interesting. Interesting. Nums.sort answer equals infinity. What could I do to make this faster? Another thing might be if I didn't use this. Like, I know for each loops are generally faster than index loops. I don't see how I can do a for each loop here because k is indexing at some distance apart. The values at some distance apart. For I in range, answer is greater than that. Yeah, I mean, I guess the other thing is like, depends on how many times the trivial case occurs. So like if k is 1 or k is 2, then like then I can handle this like if k equals 0, return 0. No, k can't be 0. If k equals 1, return 0. K is 2, then I somehow return the smaller minus the bigger. What is k? Possibly 1 to 1,000. No, okay, this 2 is not actually the smallest. Oh, it is. No. No, this is the only trivial one. And I don't know if it's even worth it to do this. Depends on how often k equals 1 is a case in the test cases. Okay, didn't change anything. Alright, well, I tried. Summary. So, let's say the logic for picking the k students would always picking k students to minimize the differences in scores would always imply, the logic would always, it's not imply, synonyms of imply, would always not suggest, it's not deduce, not inferred. Entail. Maybe entail. Would always entail. The grammar's there is incorrect. Would always require. Logic. Would always require those A students to be clustered as consecutive values in the sorted array. For example, if the array was whatever it was, like 9, 4, 1, 4, 9, 7, 7, 9, and k equals 2, only options, to minimize differences while selecting 2 are 1, 4, 4, 7, and 7, 9. All other options with non-consecutive elements. Non-consecutive elements would be suboptimal. Thus, should start by sorting, then basically select or determine the difference in low, high values of cluster by finding difference between array I plus k minus 1 and array I at I. Yeah. Do that for each possible or each valid I in the array, and keep track of the lowest difference. Okay, time plus is O of n log n to sort the array, and O of n to iterate over indices, finding the lowest difference. Overall, that means it's O of n log n. Space index is O of 1 since array is sorted in place, and I have no idea how to get it faster than 7 milliseconds. I don't know what's going on.